Hey everybody, today we're going to be doing continuity. So when we talk about continuity, we're talking about a function being continuous or not continuous. And if a function is not continuous, then it's going to have some discontinuities in there. Now there are three different discontinuities that we're going to talk about today. There's the removable discontinuity. This one is going to have a graph that has one or more points that is removed, and it's going to leave a hole in the graph. Now, when you have a hole in the graph, we say that it is a removable discontinuity. And when it's removable, the two ends of the function will actually meet near the hole, but the hole is going to be a point that's missing in the graph. So we call this a removable discontinuity. The next one is called a jump discontinuity. These are graphs that jump, leaving a graph within the range. And then the two ends of the graph will not meet when there is a jump discontinuity. So down here, you'll see that this graph has two ends, and the two ends do not meet. There's actually a hole right here, and there's a point right here. So if you could find some way to plug in that hole with that point, you would be able to make the function continuous again. But the two ends of the graph do not meet when there is a jump discontinuity. The graph just jumps from one y value to the next. And then the last discontinuity I wanted to talk about today is the infinite discontinuity. This is where you have a vertical asymptote. And whenever you have a vertical asymptote, the graph will never cross the vertical asymptote. The graph will actually start going crazy in the up direction and the down direction. So over here, I have the graph of a logarithm. And what you'll notice is as the graph gets closer and closer to x equals 0, the graph starts to display asymptotic behavior. So the graph is going to go all the way down to negative infinity, and it will never cross the y-axis because that's where the asymptote is. If you look over here at y equals 1 over x squared, where x cannot be equal to 0, you'll notice that x equals 0 or the y-axis is going to be the vertical asymptote here. So as you approach from the left, the graph is going to go crazy up in the positive direction. And then as you come in from the right, the graph pretty much does the same thing. As you approach the vertical asymptote, the graph starts to display asymptotic behavior. So an infinite discontinuity is when you have a vertical asymptote. Okay? Now, there are a couple questions I wanted to try. And what you want to do is you want to look at each graph and you want to identify the types of discontinuities. Here, for this first one, notice that the two ends of the graphs meet. There's a hole in the middle. This is removable discontinuity. And if you look at the graph below it, there's a gap in the middle right here. So that's called a jump discontinuity. Over here, where you see this graph paper, I've graphed the reciprocal function, y equals 1 over x. There's a vertical asymptote right here in the middle. So this is what's called an infinite discontinuity. And then down here, this graph actually doesn't have any discontinuities, so we call this graph continuous, and that's y equals x squared. Okay, and now this first one over here on the left side, there is a jump discontinuity because as the graph comes in from the right, it jumps from 2 to 1, so this is called a jump discontinuity. And then over here, this is the absolute value function, y equals the absolute value of x. And what you'll notice is this graph does not have any discontinuities. So we say this graph is continuous. Okay, so right here, we want to identify the types of discontinuities and where they are. For this first graph, what you'll see is there's a hole in the graph, but the two ends of the graphs are going to meet at x equals 2. It's just there's a hole in the middle. So we call that a removable discontinuity. And then over here, this graph is just a line, so it's continuous. It doesn't have any discontinuities. Okay, and now we're going to do number 3 right here. From this graph of f, we want to state at which x values the graph of f is discontinuous. So as we come in from the left, you'll see that there's a hole in the graph at -4. And since the two ends of the graphs meet, that's called a removable discontinuity. But as we go towards -2, there's a gap in the graph right here where there's a point and there's a hole down below. And we call this a jump discontinuity, right? And then as we go to the positive side of the x-axis, we approach x equals 2. And here, there is a jump discontinuity from way down here to way up here. The graph just jumps in y value. So that's why we call it a jump discontinuity. And then the last type of discontinuity that you'll see right here is an infinite discontinuity at 4, because the graph starts to display that asymptotic behavior as it approaches the vertical asymptote. And that's discontinuities. I hope that helps.